So, guys, today we're dealing with modeling quadratic functions. Okay, this is 2.4 in our book, page 39 of our student journal. And just so we're clear, when we're talking about modeling quadratic functions, we're usually using pictures and talking about how pictures and equations will kind of match up and help us out when we're looking at the two forms. So if we're looking at a picture, how we could easily come up with an equation for that, or if it's not easily, at least how we can come up with an equation. And if you have an equation, how to utilize that to make a picture, which we've already done. We've kind of went from equation to picture. Now we're going from picture to equation. Okay? So, first, I want you to work on exploration 1 with your groupies there. Okay? How can you use a quadratic function to model a real-life situation? Give it a go. You get a couple...
You know what I mean?
Hey, let's discuss this a bit. Where are the values of a positive, or is the value of a positive, negative, or 0? Okay. Volunteer, raise your hand. How do we know it's positive? Tyler? Good. If it was negative, the graph would be opening down. If it was 0, what would it be? Good. It'd be a straight line. This part would be gone. It'd be a constant. Well, no, it'd be linear in that case. Yep. Wouldn't necessarily have to be a constant, but definitely be linear. Okay? So, we explain A is positive, therefore it opens up. Okay. Part B, the expression, and hopefully do a better explanation than that. But part B, write an expression in terms of A and B that represents the year T. The company makes the least profit. So in other words, give me an expression for that least profit. Don't get it. Uh-oh. For the year they made the least profit. So in other words, I want the vertex and I want do I want X or Y value? I want the year, which would be X. How do I find this point in my vertex? T equals opposite of B over 2A. Okay? In this case, the expression would just be opposite of B over 2A. So when we put it as an equation to solve for T, there it is. T equals opposite of B over 2A. Okay? That will help us to find this. And using that information, the company made some yearly profits in 2004 and 2000, or they made the same in 2004 and 2012, so like maybe here and here. Estimate which year the company made the least profit. Yes, Kai?
Would it be 2008?
2008, how'd you do that?
Because it's in between both of them.
Good. Yeah, I find the average of the two, right? If I add them up, divide by 2, that gives me the year 2008. Okay, yeah. Oh, yeah. Yeah, I know. That's a good point. Okay, so assume the model is still valid today. Is the yearly profit increasing or decreasing, or is it constant? Tell your neighbor, increasing, decreasing, constant. Hey, how many say decreasing? Constant? Increasing? Yes, it is increasing. Volunteer, tell me why it's increasing. Yeah. Good. From this point, which is the year 2008, right? Our graph is increasing from there. Okay, yeah. Yep. Very good. Okay, we're good? Okay. Well, here's what we're going to do today. We're going to explore using these different forms. Okay? So, just so that we're clear, you have seen this form before. We've used it. You have seen this form before. We haven't used intercept form that much, but we've seen it. And there's one other form that's not on here. That is standard. Y equals ax squared plus bx plus c. Now, standard form we have also used. Our goal today Our goal today is to figure out which of these three forms we should use. We're not going to hit the 3 points yet today. That'll be tomorrow. Okay, now this is in your student journal. What page is that? 41 of your student journal. Okay. The bottom piece we're not going to hit on today, but these other 3, we will. So if you want to add standard form there, that's great. Before we dive into that too much further, notice that all of these forms have a y equals, and they each have the value x. They do all have a's. Okay, what's important to note on each of them is that when you're done writing an equation, given a picture of some sort, okay, whenever you write a quadratic equation, you must have at least the y and the x squared. Okay, that is the very basics that you have to have. Okay, you could have you could maybe not show an a, but a would be 1, right? So if I had y equals x squared, my a term is 1. So as Kai pointed out, they all have a's as well. However, a will become a number. Okay, this will become a number. This b will become a number. This c will become a number. That becomes a number. This becomes a number. That becomes a number. That becomes a number. That becomes all those things become numbers. The only thing that are left as variables when you're done with your equation is x and y. Okay? So, what you need to ask yourself when you're trying to write an equation is which form should I use based upon the information they give me. All right, so let's try that in this problem. Here's your problem. The graph shows the parabolic path of a performer who is shot out of a cannon. So this is the dude. I know. They're shot out of a cannon. They're like all happy, happy, joy, joy that they're about being shot out of a cannon. Okay? So, no, this is on my paper here, so you guys are just following along without getting too distracted. Okay, this performer who's shot out of the cannon where y is the height in feet and x is the horizontal distance in feet that's traveled here. Write an equation of the parabola, the performer, or write the equation of a parabola. Let's start with that. Okay, and then the performer lands 90 feet from the cannon in a net. What is the height of the net? Okay, well, notice, here's my scale. I'm going up by what on here? By 10. So this right here is 90. That means my net is set up right here. All right, you cannot look at you're not allowed to go, well, I think, here, let me really get a close look. Okay, I think that it's at like 23. Okay, we're calculating it. Okay, we're not estimating. Otherwise, dude, the guy misses the net, and you feel bad. Okay?
That's all you feel is bad.
So, here's the question we have. Knowing our 3 forms, which of these 3 forms should we use, and why? Okay, and I'm going to rewrite them up on top of this page. But go ahead and talk about it with your groupies. If we're going to write an equation, we have 3 different forms to choose from. Which one gives us the best choice there? Go ahead and talk about it and figure it out. Okay, let's vote. There are 3 forms. Out of those 3 forms, how many say we're using standard? Oh, hold on. Now, before we do this, do we have to close eyes to vote? Because, you guys sometimes, I'll sit here and I'll do things like this, and you guys go, I go standard, and you're like, Vertex? Okay, so it's okay, if you'll just stare at the screen and vote. That's okay. But you're not allowed to look around. Okay, so who says standard? Who says Vertex? Who says intercept? Okay. Now, I would use Vertex. Now, it doesn't mean you couldn't use others, but I would use Vertex. Now, why would I use Vertex? Okay. Yeah, they give us the Vertex. Now,
Makes life easy.
Now, guys, they tell you your vertex. Now, if you looked at this and you didn't recognize this is our old friend HK. And I understand that pain because, you know, in like 5 years, guys, seriously, I have students from last year that I'm like, hey, are you graduating? Like, I mean, you guys, I have taught over, I mean, like a couple years ago, we figured out it was over 5,000. I've either coached, taught math or driver's ed to over 5,000 students. We figured it out at one point. That was a long time ago. So keeping everyone's name straight in my head is way difficult. Remembering your face, not so difficult. The face, I'll go, oh, hey. Then I'll be like, going through the Rolodex of names. Like, okay. And then to figure out age, I remember you in clusters. Like I don't remember, like, oh, yeah, you're the class of 2019. Yeah. Okay. I remember clusters. So, like, next year if I see you and you're like, hey, I graduated, I might, like, really, what college are you going to? No, I wouldn't. I shouldn't do that. But in, like, 3 years from now, I might forget, man. I might forget your name. That is sad. So you got to remind me, like, come up and just have pity. You're like, McCoy, he's getting old. You know, he just forgets. Okay? So guys, if you look at this and you've forgotten HK, you've forgotten their name, that's okay. But you're much younger, and you shouldn't forget this one name, right? We like studied it yesterday. And I care. That's why we can't say who cares. Oh, yeah. I know. Okay, so HK, I care here. So if you could please make sure anytime you see vertex, you think HK. Yep, who cares? All right. HK. This is H. And that one's K. Now, the only problem is we still have A. Now, that's better than this one, like if we don't know A, B, and C. Oh, I guess we know C. So we could have replaced C in standard. That's the y-intercept. Okay? But in this one, we could replace all but one. Here we'd have two variables left over, A and B. In this one, we couldn't replace any of them. We don't know either of our x-intercepts. Therefore, we couldn't replace P or Q. We'd have to know where across the x-axis. So we'd have three unknowns. Whoever is banging with their pencil, knock it off. If you don't, like socially, if you don't know that that's unacceptable, dude, we got some problems. We got to talk about that at lunch or something. All right? So right here, we have to find A. If you can get it down to a single variable, you're good to go. Now, am I down to a single variable? No. How could I find A, though? Emma? So can I pause you for a minute? So I think Emma's trying to calculate it, like remember when we've done A before, we've gone over 1 and down a certain amount, and that tells us A? Is that what you're kind of thinking? In that form? Okay, now there's an easier way to find A in this one, just because this picture isn't that great. Do we know an X and Y value? Chase? The what? Yeah, we know this Y. Is that what you're saying? And we know this X. Let's use those. We can't use this one. We've already used it. But we know that X and Y. Now, we know 1 point. If we plug that 1 point in for X and Y, notice I am now down to a single variable. And once I'm down to a single variable, I can solve for that variable. Okay? Are you guys paying attention over there? Like, I can hear you. Oh, is it amazing fun? Okay. What does that make here? Do not use your calculators. My goodness. 5 times 5 is? How about positive 2,500? Negative times negative. Okay. Now we'd subtract 35 from both sides. We get 2,500 A's equals Don't need a calculator for that either.
-20.
-20. And then A, you don't even need a calculator for this. How many 20s are in 100? 5 times 25 hundredths. 5 times 25 is 125. And we're dividing by 25. Hey, pay attention. Guys, stay focused up here. Divide by 25, we get negative, or 2,500, we get negative 1/125th.
Because you have to get A by itself.
All right. So, we have our A term. Are we done with the equation? No. Write the new equation, please. Some of you think that's really easy. Some of you will make a simple mistake. So write it out. Make sure you do it correctly. Okay. Now here's the mistake that's made. That's correct right there. Okay. Now some of you may make that line a little longer and put the negative out here. That's okay as well. Okay. That is correct. Now here's the mistake that gets made. Some students end up keeping the 0 in here, or excuse me, the 15 here and the 0 here. And so this is right. This one is wrong. We frown on it. Okay. Some students write it like this. Notice what you are missing. You're missing variables. So really, right here, you have the picture of a parabola. That's what that would graph as, because you'd have multiple inputs giving you multiple outputs. Here, you have a coordinate. You have a point. And technically, if we just give you this, we don't even know where that point goes. I mean, we could say, well, okay, that's my x and that's my y, so I have one coordinate that I can deal with. Okay, and really all you're doing is doing some math here, and you can't really even plot that point. So really you just have a number here. You don't have anything that you can plot that will make a graph. You have to have x's and y's. Don't make that mistake, please. Make sure you have your x and y. Okay? How many are with it? Okay, did we answer the question? We wrote the equation. Performer lands in a net 90 feet from the cannon. 90 is an x or a y? An x. The benefit of having an equation is now you have a place to put an input or an output to get the other. So in this case, we would put a input in for 90, which will kick out an output for y. Okay? So if we want to think of it as function notation, because we're cool like that and we know functions, we could write this as f of x equals negative 1 over 125. And really, if we're trying to find 90, that means we're finding f of 90. And we know that whatever's here replaces x. All right, I believe this gives us 22.2. Yeah, 23 is close, except for they missed the net, and you're feeling bad. Okay? Huh? Yeah, unless they tell us to round, we won't round. But yeah, it would go to 22 if you round it down. Okay, any questions? All right, so it sounds like we're good. So what I want you to do, I want you to give this one a go. Figure out which of your 3 equations you have to use. So I'll put those back up there. Actually, put them up there in this way. Okay, which of your three you would use and why, and then go ahead and solve. Write your equation out. Okay, guys, to get everyone on the same page, I did a poor job at this. This P and this Q, this is where your graph crosses the x-axis. Okay, so pictorially, if you had your x and y axis, you graph that, that's P and Q, or vice versa. Okay? All right. Okay, which form who's using vertex here? Who's using standard? Who's using intercept? Okay. So on this one, they give us H and K, right? So if I use HK, I think we want to use vertex form on this one. Yeah. Okay. That way we're only left with A. We're given HK and an XY value. Okay, go ahead and finish it up there. You got it done? Okay, check your work. You know, if you haven't finished, then don't. Close your eyes. So if yours doesn't match mine, let's figure out where we don't match up. Okay, sounds like we're good. Moving on. No? Awful lot of talking, man. Not being good. Okay, so we have our HK value, plugging those in. There's our H, got our K, and then we throw in our Y and our X. Okay? All right, moving on. Number 2. Give this one a go, please. Once again, we're going to skip this part. We're just running out of time. Example 2.
One's first and one's second for P and Q.
It won't matter. Okay, how many use the vertex form? Standard form? Intercept form? Good, intercept form. They give us intercept. So now when you're looking at intercept form, okay, done talking. This form right here, it doesn't matter which one is P and Q. Okay, and please note it says X minus P. The P is this. It's just P. It's not negative P or anything like that. Whatever your intercept is, that gets substituted in for P. So if we call 4, if we want to say our intercept here is 4, when we plug this in, that becomes X minus 4. The 4 gets put in as a positive. And this becomes X minus 24. Okay? So your P and your Q. You could have switched them around because it doesn't matter if you put this quantity before that one or vice versa. Commutative property, you're good to go. So please keep in mind, if you were doing this and it was a negative 4, what would this become in here? It would become X plus 4, right? Okay, so we need one other point, and they happen to give us X and Y here. So we can substitute 9.6 and 0. We crank it out. It's 9.6 times 96A. So we get 1a equals 1/10. Okay, let me pause there. Anyone, any questions up to there? Aaron? -4 times -24. Yeah. So we get a times -4, 0 minus 4 times 0 minus 24. Okay? So writing our equation, y equals 1/10, x minus 4, x minus 24. Cool, we wrote our equation. Letter A says write a function that models it. We've done that. What is the coldest temperature? Talk with your groupies real quick. How are you going to find the coldest and then do it?
Find the app first. Yeah, but to find your x, you can just
Yeah, everyone's attention back up here, please. Volunteer. How do we do it? Emily. Yeah, we could. Good. We could just find the distance between the two intercepts to help find the vertex, right? So we're looking for the vertex, and if you have intercepts, just add them up, divide by 2. This is 14. Now that 14 is hours. Is that what we're looking for? Oh, we're looking for temperature. So how do we find it using the 14? Josh? Good. Plug it in as an input here. Okay. So 14 minus 4. And 14 minus 24. -10? I think that's 10. That one's -10. That's one -100, and 1/10 of 100 is -10. And that is Celsius. Hey, now for those of you that said, well, why didn't I just look at the graph? Well, we could have, except for it's kind of, and we don't know necessarily that it's zoomed in. You know, we got to double check. Plus, that wouldn't make the math as fun. So, all right.
I'm so happy. You're like, haha, you did the math.
All right. Everyone's attention back up here. You guys, you're talking in between, like, costs you class time every time. Okay, unfortunately for you, like, the lessons in here go way long right now. So if you talk every time in between, I have to get your attention back. It makes it tough. Okay, so you guys think we have this? So when I'm passing out your assignment for today, I'm going to put up one more problem for you. See if you really get it. There it is. Nope. Oh. So if you're saying no, let's see where we mixed up. Here are your steps.
It's really not. It's really.
It's a lot of plugging each other.
Yeah.
All right, Haley. Yeah, it's +2 because this is a -2. Yep. So it's really x minus -2, which becomes +2. Good call. How many made a mistake there? Okay. Any other questions? All right. I want you to take a look at your student journal, page 42. That is your assignment today. All of it. Yep. All 8.
Is it going to be due?
Yep. Be due tomorrow. Woo!